Hi, welcome. What you are seeing right now is yet another dude trying to become a professional programmer. Yes, I am very special. So I've been going for a little while and I want to tell you about it. Because maybe you care, maybe you don't. I don't care, I'm telling you anyway. So yeah, I've been programming on and off as a hobby for actual years now. Mostly just for fun, nothing serious really. And 90% of that time was just me failing to make video games. You know, starting new projects, eventually dropping them and throwing them onto the ever-growing pile of unfinished games. Ever-presently looming over me, reminding me that I am a failure. Actually, my first ever programming language was PHP. Don't ask, I don't know. And then I learned BASIC and messed around with that for a little while, but also that never really went anywhere. But a little while ago I thought, you know what, why not do this for real? It's a ton of fun, I already know the basics and I've always been a quick learner, so I just learn the stuff I need to know to actually create like useful software, and then hopefully at some point I'll get some kind of paid work. Because let me tell you, working in some random office my whole life is not the way to go for me. And also, you know, big money, baby! So after a quick YouTube search, some very trustworthy bros told me it only takes like 6 weeks. So I'm 5 weeks in by now, so I'm guessing next week I'm going to be super rich. I hope so, because I already bought a new aeroplane. I'm in crippling debt, please help me. So kind of on a whim, I just decided to start with C#, because I feel like it sits somewhere in the middle between these high-level languages like Python and some super low-level stuff like C, so I can learn some more fundamental programming concepts without having to deal with like super low-level memory management stuff. Eventually. So I took this totally real, totally legit C# book, definitely not a PDF I printed at work, and got to work, learning the basics of how the language works. But learning means nothing without practice, so after spending way too much time thinking about what would be the most perfect, most optimal project to start with, I just decided I don't care, I'm just gonna work on the thing that I wanted to work on from the very beginning, the music cheat sheet tool, as I call it. A small little tool that can tell you things like musical scales and chords and stuff, not by having them memorized, but generating them dynamically based on intervals and the rules of how these things are built. So for example, these are the number of half steps between each note of a major scale. And by taking the first, third, and fifth note of a major scale, you get the corresponding major chord. I'm a huge music nerd and shit like this excites me to no end. So I got to work using this stuff to get a grip on how to use C#. And I gotta say, I'm really having a great time. Well, first of all, I'm making something that I want to make and I'm passionate about. I want this to exist, and that helps a lot with persevering when you get stuck on a problem. But also, C# is just an enjoyable language, I think. I've used Python a lot, and compared to that, C# feels like rock solid, you know? Working with Python feels like throwing something together quickly with like sticks and duct tape, and C# feels like building a house with bricks and mortar. And I like that. Anyway, here's a quick overview of what I've got so far. So kind of like the backbone of this whole thing is this one array here. It contains all 12 notes as a string of its name, which means I can represent or reference them by either a name or a number, which is the corresponding index. Like I said before, I can create a scale. I have all the different scale types as arrays of intervals. I can calculate any scale with any root and print them out with names. And whenever I want to add some scale type, I just have to add one array with intervals. I can create all 12 versions of that scale. I can create chords in all qualities based on intervals and the root node, which work the same way as the scales work. And yes, whether or not like sus2 and 4 are qualities or not can be debated, but for the purposes of this program, it makes all the sense to treat them as qualities, so shut up. And I can get all the chords of a given key by harmonizing over each scale degree, which is done by starting at each note and skipping one until you get a triad. And it even works with scales where it doesn't make any sense, like a pentatonic scale, which gives interesting results. And then I have a bunch of helper functions for some stuff, like this function I use a bunch to validate notes after I do some math on it. For example, I have the note B, which is the number 11, and I add 3 to that. I get 14, which is outside of the note array. So I need to sort of wrap around. In that case, that would turn into 2, which is the note D. This is going to be important later, by the way. And some other stuff, mostly stuff to do with arrays, like adding a number to each entry in an array, or turning an array into one string so I can easily print it out. So, and to access and test all these things, I've just quickly written a basic CLI to like request things like chords and scales. Because the approach I kind of want to take with this is, I think all the music stuff is sort of written as a backend or a library of some sort. And at some point I want to create like a front end for that with a GUI and stuff. So that CLI is just a temporary thing, and I don't care about being well written or stable and stuff, because I'm going to replace it anyway, and the only one who's going to use it is me, and I don't care. And the way it works is I just take an input, split it into words, and just one by one go through them, check if it matches a set of words I predefined, and then pass all the relevant information to a function to request whatever I wanted to request from the back end. So as I said, it goes through each word in order and saves them into one of these 4 variables if it matches any of the predefined words. So it ignores any word that doesn't match. And also it overrides any match that came before. I mean, that's not ideal, and also there are many ways to break this. But I know how to use it, and no one else is going to use it, so it's fine for now. So now, finally, we can get into the actual topic of today. The next feature I wanted to implement is to recognize a chord based on any given set of notes, which seems deceptively simple at first. I mean, if I see a chord played on the piano, it's pretty simple to just look at the shape and then get the root and say, okay, this is C major, for example. But the more you think about actually implementing that in code, the more problems come up. First of all, I want this to work with inversions and notes that aren't in order in general. So you don't always know the root note, and you can't just compare them to the intervals of a chord quality. And also some chords, for example A major, even if they are in the right order, they sort of go over the turning point of the array. So the first note is actually the highest number, and that makes comparing intervals even more complicated. My first idea was to check for intervals that are bigger than 4. Because if you look at the intervals of major and minor chords, there is never an interval that is greater than 4. So if I get an interval that is 5, I know that I have an inversion, not the root position, so the first note is not the root. But that was quickly ruined by the augmented chords, because augmented chords always have an even interval of 5 no matter the inversion. Also, sus chords have an interval of 5 in root position, so that's out the window. So this is editing, man. I just want to make something clear for those of you who don't know about music and stuff. The sus in sus chords stands for suspended, because they sound like that. I just wanted to make that clear, because I know that word has been ruined forever, and I'm not immune as well, as you will sadly see in just a moment. And as I sat there on my piano, counting intervals and trying out some stuff, I encountered another problem. This is where the clip comes. Well, hang on. Okay. This is C augmented. 1, 2, 3, 4, 1, 2, 3, 4. And you first inversion. That's also D augmented. E augmented, I mean. And that's G sharp augmented, right? So, the augmented chord. These 3 notes, that is C, E, and G sharp, that's C augmented, that's E augmented, E, G sharp, C, and G sharp augmented, G sharp, C, E. So it's 3 at the same time. God damn it! Why can't it be easy? And again, those sussy chords can also be 2 chords at the same time, so another problem added to the pile. But actually, this realization will come in useful later. Hey, it's Editing Man again. Do you ever look at what you're doing and just think, how the hell did I get here? I just typed sussy twerk GIF into Google. What am I doing? What is happening? So there I was sitting, a little bit lost, feeling defeated. But as he so often does, someone came to the rescue. For those of you who don't know, the circle of fifths is kind of like the big daddy of music theory. and the best illustration I found of it is this one. I won't go off geeking about all this stuff here. Trust me, I could. There's a lot here, but all we're interested in right now are these things down here. This is a major chord as arrows mapped onto the circle, which creates a shape. And that gave me a wild idea. I do know a thing or two about vector math from making video games. For those of you who don't know, a vector is a math concept in terms of a coordinate system, which instead of referring to a position, it's kind of like an arrow pointing to that position. So it's kind of like a direction, or you can also treat it as an angle. And yeah, these are arrows, or vectors. So why not try this? Turn the node into a vector pointing to a node on the circle, and then compare them via the angle between, which sounds crazy, but it might just work. First of all, it's circular, so the whole problem of wrapping around nodes over 12 is kind of irrelevant. And if you put the nodes in order based on the order on the circle, we at least get the right order to start comparing the angles. But we still don't know which one comes first, so we don't know the root. But remember when I said the augmented chords thing will come in later? Yeah, later is now. So as we've seen before, in an augmented chord, any of the 3 nodes could be the root node. So firstly, that made me realize that we can't just find one single chord, but I need an array of multiple chords. And second, that also means we have to try each inversion, i.e. treat each node as the root anyway. That solved the problem of not knowing the root. We try each possible order and then check if the list of angles matches any chord quality. And that gives us the following process. We get 3 nodes, we turn them into a vector on the circle, we order them, we get the angles between them, and then we check if they match any of the predefined angles of a chord quality. If they do, we can create a chord with the root node, which is the first arrow/node, and the matched quality, and then we add that chord into an array. And then we invert the nodes/arrows, so we put the last one in first place, and repeat the whole process for every node. And in the end, we have an array of possible chords. Okay, sounds good. We can write code now. I don't want to bore you with too much vector math, so I'll just quickly go through it. So first we need a function to turn a node into a vector on the circle. First we get the index of the node on the circle. We have 12 nodes on the circle, so each node is a 30-degree increment. So we take the index and times that by 30 to get the angle of the arrow. To get to a vector from an angle, you first need to turn the degrees into radians, which is done with this formula. And the cosine of the radians results in the x component of the vector, and the sine results in the y component. We combine these two into a vector 2 and return it. Now we add a function to turn a vector 2 back into a node. To do that, we first need to turn it back into radians by using the arctangent 2 on the x and y component, and then turning the radians back into degrees, and then dividing it by 30 to get the index on the circle. I make it sound really simple and easy, but I got stuck for like an hour because I swapped the x and y here.
I think I know the problem. Maybe I do know nothing about vector math. Yeah, that goes the other way around, right? Well, there we go. Wow. It was just this small thing. You know what? You want to know what programming is like? Losing like 2 hours of your life, going insane, questioning everything, your life, your brain, your sanity, because of a small mistake like that.
Next, a function to get the angle between 2 vectors. We get that by calculating the dot product of the 2 vectors, which C# has a function for, but for the weird people out there, if you want to know, that's the formula there. And you can get the angle from a dot product by using the arc cosine, but that only returns angles between 0 and 180. So we use the cross product of the 2 vectors to determine if the angle is bigger than 180, and if it is, we turn it into a full 360-degree angle. We need a function that creates an array based on angles between the vectors, a function to invert the array of vectors, and then a function to turn an array of nodes into an array of vectors. And we need a function to sort nodes based on the circle of fifth by just looping over it and finding the index of the array. And now we can finally start to write the function to recognize a chord. We get the array of nodes, we sort them on the circle, we turn each of them into a vector, put that into an array, we loop over each given node, get the angle between the arrows, put them into an array, and in a for loop we compare the angle array to each quality angle array using this weird function here, and if it matches we create a chord using the first vector, we turn that back into a node, getting the quality by doing some weird stuff here with 2 arrays because I don't know how dictionaries work in C# yet. We put that chord into an array, and then we invert the node vector array, repeat that for every node we've been given, and in the end we return a vector array. First take, baby! Now, we finally have a function that can hopefully recognize a chord based on notes in a random order.
Please, that is the moment of truth. Yeah, it's C-sus 2 and G-sus 4, which is correct.
And it works. It actually works. Quick aside here, I couldn't find a good spot to mention this organically, so I'm just throwing it in here. One thing I did is I created a file to sort of test my code, in quotes. For example, to test the create chord function, I just created an array of every possible chord it can create and filled it with the right values, and then used the function to create every possible chord. And then I check the results against the fact arrays, as I call them. And then I can print it all out in the console and mark the things that aren't matching in red. So I can not only see when something goes wrong, I can see what and where it went wrong. I don't know if that counts as test-driven development or unit tests or whatever, and I don't care. It works and it's infinitely useful. Trust me, this is the best thing ever. Whenever I change or refactor something, I can just quickly type in test and immediately see if I broke something or not. It took some time to set this all up, but the amount of time and potential aneurysms I saved with this make it well worth it. And now I can just integrate that chord recognition into the chord creator test and see that it actually works across the board. It's just so useful. Anyway, so back to the topic. I was hyping hard over that green message telling me that everything works. I was proud. And rightfully so, I think. But that was also the time that I kind of started to slowly realize that all of that vector math stuff, as cool as it is, was completely and utterly unnecessary. Well, kinda. If you think about it, the order of notes on the circle doesn't really matter. If you order them chromatically, you get different arrow shapes and angles, but the process is still the same. And if you straighten out the circle into a row, instead of angles, you get a number of steps, i.e. intervals. On a list that looks suspiciously similar to my normal note array there, the only problem now is when chords go over the endpoint of the array, because then you get negative intervals, but you can solve that problem pretty easily. When you get in the interval between the two notes, you just check if the second note is higher than the first one, and if it is, you just add 12 to it to quote-unquote wrap it around to the top, and then you have the actual interval of the notes. And so I did that. And that works as well, of course. And it's a lot simpler. So, yeah. Now you might say this was all a tremendous waste of time. But I don't think so. This is not me coping, okay? First of all, I had a lot of fun doing vector math because I'm weird like that. And this whole thing is supposed to be a learning exercise. And I learned a ton from all of this. And I will bet away my left ass cheek that rotating around the circle of fifths is going to be useful later on. And lastly, but most importantly, it got me to the solution. And that's all that matters in the end. And in the end, the actual solution here is a very small and comparatively simple little function with just two little helper functions. But size and complexity of code is no indication of how hard it was to get there. So if you're learning right now and you just spent 2 hours writing a 14-line function, don't think you're doing something wrong or you're not good enough. Just because you keep seeing people on the internet in tutorials writing out perfect code on the first go. This isn't real development. They're either copying from someone else or they spent the time beforehand arriving at the solution there. And that brings me to another very important takeaway from this whole ordeal here. There are many ways to find a solution to a problem. I mean, you can look it up online if you're weak. Other than that, most of the time it's going to be one of two ways. One way is the way I got to the solution this time. Break down the problem into smaller problems, think of something, and then keep going to see if it solves all the problems. I mean, it worked this time, but maybe a more reliable way would be the second way, which is to break down the problem into smaller problems and then one by one tackling each problem, combining all the solutions into one. I could have probably arrived at the same solution with that approach, I'm sure. But it doesn't really matter. One method isn't strictly better or more right than the other. But they do have one important thing in common. They start with breaking down the problem. Breaking down one big problem into many smaller problems is, in my opinion, one of the most important skills you will need as a developer. Programming is problem solving, and you can't solve a problem you don't understand. It does not matter what you do, which language you use, which tool you're creating. As long as you keep solving new problems, you will improve. Be mindful about how you break down problems, write it down, whatever, and you will see the improvement over time. It's going to be tough and frustrating, but it's worth it. Because in the end, you have something that didn't exist before. Because you made it. And that's awesome, isn't it? Well, this took a weird inspirational turn, huh? Anyway, I made it! I reached a big milestone I set for myself with this project, and that feels great. I'm gonna take a break from this project now, focus on one or two smaller projects. But here's some future plans I have for this project. First of all, I need to clean up this horribly ugly code. Most importantly, I need to learn how to use dictionaries instead of using 600 arrays. I will use this project to learn how to create GUIs with C# and write a user interface that uses this code as sort of like a backend. Right now, chord creation and recognition only works with triads, so no extensions like 7s, 9s, add 9, whatever. I'm a little afraid of that because it makes everything so much more complicated. And 200 other things I eventually want to add, like chord progressions, notations, integrating sounds, so I can actually play the notes, scales, and chords and stuff like that. But that's all far future stuff that isn't even planned yet. The next project is going to be a smaller, hopefully less chaotic Python project. But until then, I hope you got something out of this whole thing here. Maybe you learned something or at least got some entertainment out of that. If not, well, I don't care. I'll keep going. You're gonna keep getting what I'm giving you. And now I'll leave you with the sound of me playing guitar in the background because I forgot to turn off the screen recording. Bye bye.
Oh shit.